Now I am giving you all of the parts to make this. They're on D2L, so you can download them. You don't have to make any of these parts yourself. You just have to put them together. And they're just standard makes like we learned previously. Okay. So you'll recreate the assembly, and then you're going to use your assembly to create the drawing as shown in the PDF that's on D2L. So that looks like this. Okay, so here it's a 3-page drawing. So here's the first page. It's just standard views and some dimensions. The second page looks like this. So this shows an exploded view, a bill of materials, balloons identifying the different components in the bill of materials. So we'll show you how to do these operations. And then finally the third page of the drawing is some of the specialized views, the section view, an auxiliary view here, a detail view, and some dimensions. So some of this is similar to what we did last week or a couple weeks ago. A couple things here are new. So we'll show you the steps that you need to create this drawing. Okay, so then you're also going to create 2 different configurations of this assembly in one assembly file. Okay, one of them for direct viewing, the other one using a Canon camera. We'll talk more about that. Then we're going to adjust the parts as necessary to let the camera mount version pivot a full 360 degrees without interfering with the base plate. And then we're going to save the assembly as a part file. Okay? So you're used to saving the assembly file, but we're going to show you how to take this assembly and save it as a single individual part file, an SLD PRT file. And then finally, we'll take that part file and save it as an STL file, which is the kind of file that you use with the 3D printers. So you could actually go and print this if you wanted to. So what you'll turn in is 3 files. One of them is going to be your PDF of the drawing. Then you're going to turn in your SLD PRT file, where you save this assembly as one single part. Okay? Again, note that this is a solid part file, not an assembly file. And then finally, you're going to turn in your STL file, which is the format that the 3D printers accept. So this will get you, with today's class, you'll know everything that you need to know in order to go actually start using 3D printers and taking your models, sending them to the printer. Okay, so that's an overview of what you're going to be doing this week. And I went ahead and put the assembly together since there's nothing new there. I don't want to waste your time watching me do these operations that you already know how to make. So let's just open this up. Okay, so here's the telescope. And when you've got it all put together, it should be able to rotate like that. So you can rotate around to point it in different directions. And also, if I temporarily fix that rotation, you should also be able to pivot it up and down to change the angle at which it's looking. So now if I look at, say, a top view, what I want to do is have this rotation oriented in a way that it's going to be kind of facing straight down. So that if I looked at the right side view, okay, it would be just, I'd be looking straight at the side. I don't want it rotated at some odd angle. So the easiest way to make that happen is to go ahead and simply mate one of these side plates to be parallel with the right datum plane. So we can go to mate, choose the side plate, choose the right datum plane. They don't need to be mated, they coincident, they just need to be parallel. Okay? Okay, so this is the direct view version of the telescope. So this little eyepiece, you put your eyeball right here, you look through the telescope. The light coming in reflects off of this main mirror at the back, reflects back to this secondary mirror at the front, and then reflects off of that, goes through some lenses of the eyepiece, and comes up here to where you're looking in through the eyepiece. Okay, so one of the things you saw in the drawing was that we're going to create an exploded view of this telescope, where all the parts are separated. You know, you've seen these lots of times. Anytime you buy something that you have to put together yourself, they usually give you an exploded view to show the locations and actually define that exploded view as a configuration in the assembly model. So we need to do that before we create the drawing. Defining an exploded view is actually pretty easy. You've got, on the assembly tab, you've got a button right here for creating an exploded view. You just click that button, and then you can click on a component in your model, and a triad, these three handles will pop up, and you can click on any one of these handles and simply drag the component in that direction. So for example, I can click on that red handle and drag the side plate out to the side. Then I click on the gear and slide it out to the side, do the back side plate, side gear. So this is very straightforward. We can drag components vertically as well. Drag that down. And you'll see each time I drag a component, it's defining that motion using an explode step here. If you wanted to get really precise, you can put in precise distances right down here, but usually, for our purposes, it's good enough to just position things, make them look good by dragging them on the screen. Now, if we wanted to drag one of these holding rings, suppose we want to drag it along the axis of the telescope. That's the direction that makes the most sense, but none of our triad arrows are lined up in the correct direction. What you can do is right-click on that blue dot in the center of the triad and say Align To, and then you can click on some other surface and the triad will rotate to be normal to that surface. So now we've got a handle oriented just in the right direction. We'll do the same thing on this back holding ring. Click on it, right-click on the blue dot of the triad, say Align To, and then click the front face of that surface. That rotates the triad, and we can drag that back. Okay. So once you get the components positioned the way you like, just go ahead and click the check mark, and you've now defined the exploded view of your assembly. That exploded view is saved on the Configuration Manager tab. Okay, we've spent most of our time looking at the Property Manager here, but notice there are 4 different tabs. We've got the Property Manager here, which we've seen sometimes an Appearances Manager, but this third tab is called the Configuration Manager. And if we expand the default view, this is where that exploded view resides that I just created. So if we want to put the pieces back together, all we have to do is right-click on Explode View 1 and say Collapse. And it's back to the fully assembled version. If I want to explode it again, just right-click and say Explode. Another thing that's kind of neat here is you can actually, if you right-click, you can animate the explode steps that you define. So click Animate Explode, and it will do those steps in the same order that you created them, and you could even save that as an AVI file or a movie file. You could put that into PowerPoint if you wanted to see your assembly being taken apart. It's just a movie file, completely independent of SolidWorks. You can also animate the collapse process if you wanted to show how it goes together. Just right-click and say Animate Collapse, and you can see all the parts going together. And again, just use the little Save button if you want to save that movie file. Okay, so do you have any questions about defining the exploded view or anything we've done so far?
I'm a little confused about what we were turning in. You said that we were turning it in as just a part file.
Mm-hmm.
So does that mean that we're going to take our assembly and just save that as one part?
Right, and I'm going to show you exactly how to do that.
Okay.
But yeah, that's what you are doing. Any other questions? Okay, so while we're on the Configurations tab, this is a good time to talk about actually creating multiple different configurations of your assembly. Because a lot of times we might want to show our assembly in different states of operation. Like if you're modeling an airplane, you might want to show it with gear up and gear down, or flaps up, flaps down. And you don't want to save a different assembly file for every one of these different configurations of your assembly. We can create multiple configurations and save them all in one assembly file. So what we're going to do to illustrate this is replace this direct view telescope with a different version of this part that has a little box on the back representing a Canon camera. Okay, so that'll be our camera view telescope. So The configuration that we first defined is just, it's called default, but let's call it something more meaningful. Let's just rename that and go ahead and call it direct view. And to create a new configuration then, I right click on the top level assembly and say add configuration right here. Okay, I can give it a name. I'm going to call this one camera view. There's a few other options that you can look at. I'm just going to accept the default options as far as defining the configuration. And what I do now is put this assembly into the state that it should have for the camera view configuration. So what I'm going to do is insert another component that you are provided on D2L. It is the telescope with Canon part. So open that and place that in the assembly. And what I want to do is replace this direct view telescope with this Canon camera telescope. I don't want to delete the original telescope though, because I still want that available for the other configuration. So instead of deleting it, what you do is right click on it and simply say suppress. Okay? It hides it, but it's still in the model and all of its mates are still valid. If we go back to the feature manager, you can see anything you've suppressed will be grayed out like that, but you can always right click on it and unsuppress it to bring it right back into your assembly. So let's suppress that guy and then make this telescope into the proper position. So we'll make that surface with the inside surface of the holding ring. Let's do an offset from that front surface of the telescope to that front surface. Offset it by 3 inches. Flip the alignment. Okay. And then the last thing I need to do so that it doesn't rotate anymore is I want to make that surface and just make it parallel with that surface, and that'll fix the rotation. Oops. Okay, so now back on the configuration manager tab, so now this is defined as our camera view configuration. If we double click on the direct view configuration, notice that configuration now has both telescopes in it, so we simply need to suppress the camera view telescope from that configuration. So just right click, suppress. Okay, so here's our direct view configuration, double click, and here's the camera view configuration. Okay. So it's a very nice way to save multiple setups of your assembly all in one file. So you can quickly switch back and forth. Okay, so here's our camera view telescope, and suppose I take this and want to look straight up. Well, I just rotate this telescope to start looking straight up, and what's the problem that we have? Well, the camera bangs into the bottom of the base plate. So this interference is pretty obvious. But certainly in assemblies you might have something that's just a very close clearance and you want to find out if it's actually going to collide with some other part. So remember last time I think we looked at the move component button and we used physical dynamics to try and model the motion of those gears. Well, another option you have there is collision detection. Let's see. If I turn on collision detection, and I'll go ahead and choose to check all components and stop at collision, highlight faces, and we have speaker to play a sound. But if I now click and drag this telescope, started like this. Okay, that ring got messed up. I'm not sure how that happened. Let's fix that. Okay, now go back to move components, collision detection, all components. Okay, so now if I click and drag on the telescope, when it reaches to the point where it collides with the base plate, you'll see it stops moving and the base plate and the camera highlight to show where it collided. So that's a nice, easy way to check for collisions. Okay, SolidWorks can help you there. Now, as soon as I click the check mark and close that box, it goes back to the normal way where it doesn't care if it interferes. So that's just going to show you if things interfere, but then you have to go fix them yourself. Now, what would we do to fix this problem that we're having with the camera?
Move the lens up.
What's that?
Like shift the entire tube up through the rings.
Okay, we could shift the telescope forward, although there's actually a good reason that it's positioned where it is, and that's to maintain the CG, the center of gravity of the telescope, right along the pivot axis. If we move it forward and the CG is up here, then the telescope's always going to try to like drop nose down. So that's a good option, but what if we wanted to leave the telescope where it is? What else might we try? Okay, we could raise the height by adjusting the height of this part, right? So what we can do is, if we want to modify one of these side plate parts, we can just right-click on it and go up to the shortcut button that says Edit Part. Okay, and when we do that, this may look a little bit familiar from when we were creating that tower for the wind generator, and we were doing it in assembly mode. This is kind of back into that same mode of operation, where the part that we're editing is turned blue, everything else is somewhat transparent. But this allows us right here in assembly mode to go ahead and double click on the feature we want to modify. The current height is 14 inches. Let's just make that, let's just try 18 inches. Regenerate the part. Okay, that looks pretty good. Yeah, that gives us plenty of clearance down at the bottom. So we'll accept that as our new part. Okay, and now we've got plenty of clearance. So once you've modified the part, what your homework assignment asks you to do is, first of all, point the telescope straight up so that the clearance is easy to see. So we can do that just by mating the bottom surface of the camera with the bottom surface here of the stand and just make those parallel. Parallel, okay? So now you can clearly see that we've got space in between those components, and in this orientation now we want to take our assembly model and save it as a single part file. Okay, so we do that just by going to File and Save As, and we can change the Save As type from assembly to, in this case, we just want the part file. Choose SLE PRT. Now what you should do here is choose all components. I'm going to omit that step first to show you what happens if you forget to choose all components. If I just change it to part and say, so put it on the desktop and say save. Okay, now let's go to the desktop and open that part. Okay, so it says, do you want to proceed with feature recognition? So what's happening, when I save this assembly as a part file, all of the different components now are what's called dumb solids. They don't have any real feature information in them anymore. It doesn't know what's an extrusion or what's a revolve or what's a sweep or anything like that. But this feature recognition is SolidWorks saying, I'll try to figure out how these parts were made if I can. Okay, if something is just a cylinder, SolidWorks will probably be able to figure out, oh, I could make that as a circular extrusion, and it would apply that operation, or infer that that's the operation that made that part. Sometimes it works okay. Usually I just tell it, no, don't proceed with feature recognition, and so you still got the parts listed, but again, there's no feature information in them. You can't expand these and see the extrusion or the cuts or anything else that made those parts. They're just dumb parts. Now, I think, in spite of what I told you a moment ago, I think this actually worked okay. If I do a section view, okay, yeah, this actually did just what it was supposed to that I didn't think it would do if I didn't choose all components. But you do have solid material here, which is shown in blue, and this would probably be okay to print. Now, normally, if you forget to choose all components, what SOLIDWORKS does is actually just not even recognize the solid material, it just copies the external surfaces of each thing you see here, so you don't have any solid material in your model, which would make it impossible to print. So just remember, when you're in the assembly and you're doing a file, save as, part, just to be on the safe side, do go ahead and click the All Components button. Okay, and that way it'll save the solid material like it should. Okay, but anyway, now we've got our telescope model assembly saved as a part file. Okay? And the next thing that you're asked to do in your homework is save this as an STL file, which is the actual file type that you would send to a 3D printer. So to do that, you just go back to File, Save As, change the Save As type to STL. Okay, now this one I know is important. Make sure you click on the Options button and make sure that your units are set to millimeters and your resolution is set to fine. Okay? By default, it usually comes up as coarse, which means circular features aren't going to look as circular. Like you see here, it's going to approximate a circle just with straight lines, and it's not going to be very smooth. If you go to fine, it does a better job of approximating curved features. It's still doing it with lines. If we zoomed in here, you see a bunch of little straight lines, but it's got a finer resolution, so you're going to end up with a smoother, better result. So make sure you choose millimeters for units and fine for the resolution. And then click OK. And click Save. Okay, so this now is the STL file that it created. And you can see what it's done is replace the solid geometry that we had with a bunch of triangles. Okay, this really is just a point cloud of individual points with all their X, Y, and Z coordinates, and of the X, Y, Z coordinates of each node or each vertex of the triangles that you see here. And you can see with the fine resolution, places that have curves, you have a lot of small triangles, and the places that are just big and square and blocky, like this camera, have relatively few triangles. Okay. Now, usually SOLIDWORKS does a pretty good job of generating the STL files. Okay, but any program, SOLIDWORKS or ProEngineer or CATIA or any other modeling program you use will occasionally have problems with the STL file. Okay, sometimes you might have a vertex that's just omitted, and you've got a hole in your STL file. And if that happens, it might be obvious, it might be something you can just look at and see, or it might be something that causes an error when you go to remove your host and try to slice it for the 3D printer. But if that happens, there's a really nice resource that's available for free, and it's called NetFab. Okay? Marker. So write this down in your notes. Even if you're not on the 3D printing subgroup for your project, this is still good information to know. cloud.netfab.com is HTTP. This is a cloud service that you can use, and it's free. All you need is a Microsoft login. But what you can do is take an STL file that you generated in SOLIDWORKS, and if it's got problems, if it's got holes in it, you can upload your bad STL file to this site. Their software will analyze it, identify the holes or other problems, and fix it, and you just download a new repaired version. Okay. So cloud.netfab.com can help you fix your STL files if SOLIDWORKS does not generate it correctly for you. Okay. But anyway, that's what the STL file actually looks like. And that's what you would send to or that's what you would open in the Repeater host software on the 3D printer computers, and you would start working directly with this file right here. Okay. So for your homework, just remember you're going to turn in your solid part file version of this telescope, and also the STL file that I just generated, okay, along with the PDF of the drawing, which we'll talk about next. Okay, so do you have any questions at all about any of the stuff we've done here in the assembly before we take a look at the drawing? Exploded views, multiple configurations, modifying parts in the assembly mode, saving it in different versions.
From our single part, can we still look at the exploded view and the different variations of our configurations?
Not from the part file. When you save it as a part, pretty sure you don't have any motion in it anymore. Your configurations are just what you see on the screen. So the exploded view and those different configurations, you have to have the assembly file for that.
Okay.
Good question. Any other questions? Let's close that one. Let's see. I'm going to go ahead and put that assembly back to the way it was for purposes of the drawing. And okay. Okay, so now we want to show you anything that you don't already know to produce this 3-page drawing of your assembly. Now, to start the new drawing, of course, we could just go up to the File, New Drawing, New Document button, or another option you have is to go to File and say Make Drawing from Assembly, and it will go ahead and start your drawing. You can say ANC Landscape. These options are fine, and it knows what model you're working with. So, of course, for sheet 1, the easiest thing to put in those 3 different views would just be to do a standard 3 view, say check mark, and it throws the 3 views in there for you. Now, these are smaller than what you want in your PDF. This sheet scale is 1 to 20. How do we change the sheet scale if we want it to be something larger? Remember? Okay, right click on the sheet, go to Properties, and we could make it 1 to 12 right there. Okay, and then, let's see, what else? On sheet 1, you're going to put in some dimensions. You remember, just use Smart Dimension to do that. You're going to put in isometric view. That's just done using the Model View button to put in an isometric view. How do you put your name in the title block? What do you need to do to put that in? Very good. Right click and say Edit Sheet Format, and then you can double click and you can type whatever you need in the title block. Put that button to go back. Also notice that you want the hidden lines to be shown in this right side view. Okay? So in our drawing, how do we make the hidden lines shown for this view only? To change the display state, we just click on it and go to this option to show hidden lines. Okay, so that's what you would want for your right side view. Okay, so I think you know everything that you need to complete sheet 1. So now let's move to sheet 2. That's where we put in the exploded view and the bill of materials. Now, first thing you need to know is how do you add another sheet into your drawing? And I promise this is something we always require on the final exam in here, is to make a multi-sheet drawing. So this is an easy 10 points on the final exam. Remembering how to create a second sheet in the same drawing. You can do it just like you do in Excel. You go down here to the bottom and click on the little tab that says Add Sheet. Okay, that's one way to do it, and that brings up a new blank sheet 2. Or you can go and right-click on your sheet in the model tree and choose Add Sheet from there. Either way. Now, for sheet 2, we want to turn off that title block so that we have more room. How do we turn off the title block in our drawing on this sheet? How do we turn off the title block? You remember where that command is found? Anyone? Anyone at all? Okay. Right-click and go back to Sheet Properties. This is also where we change the scale, but just uncheck that box that says Display Sheet Format. Okay, say OK, and that turns off the format on that sheet, but sheet 1 still has just like we left it, just like we want the title block. So for sheet 2, now we want to put in that exploded view. So you can go to the Model View button. Yeah, we want the telescope model. Let's turn on the preview checkbox, and we want to put this in as a isometric view. So, okay, now notice one of the options we have in our Model View Property Manager now is to choose what configuration we want to show. Okay, we can do the camera view configuration, or we can do the direct view configuration, because both of those are defined in our assembly. And if I do the direct view configuration, notice it also gives me a checkbox now to say show an exploded state. Okay, I don't have that checkbox when I did the camera view because I was actually looking at the direct view when I defined the exploded. So here's a hint for your homework. Since you want the camera view as the exploded view, make sure this is the view, the configuration you're looking at when you define those explode steps. Make sure you've got the camera view or the camera version in your model. Because if you do, then you'll be able to just choose that configuration, click the checkbox that says show an exploded state, and then go click to place it, and that's how you get your exploded view. Okay. Let's make that maybe 1 to 10. We'll make it a little bit bigger. Okay. Now, it comes in oriented not in the right direction. I'd like it to be pointed around the other way. So what we can do is use this button right up here that says 3D Drawing View. It lets, if I click that and then click the Drawing View, it lets me rotate this using the middle mouse button just like we're used to rotating our model. So we can reposition this into any orientation we want to. Okay? Okay, so that's how you put your exploded view into the drawing. Now the next thing we want to do is generate this table. This is called a bill of materials. And we do that by going to the annotations tab and going over here to the right where it says tables and choosing bill of materials. Okay? Sometimes people just call this a BOM for short. In industry, sometimes you'll hear this referred to as a BOM. I remember when I went to my first engineering job at Sandia National Labs, one of the senior engineers handed me a big stack of drawings. It was like 50 sheets. It was a drawing package for a satellite, a space satellite that we were working on. And he handed me this drawing package and said, here, go create a bomb for this. And I got excited because I thought, that sounds like fun. I thought we were going to blow something up. But he was actually just talking about one of these bill of material tables. And I had to generate this manually. There were thousands of parts in this thing, and that was not fun at all. But with SolidWorks, it's actually fairly automatic. If you just click the right button, SolidWorks fills in all this information for us. So in SolidWorks, we go to the Annotations tab, go to Tables, and choose Bill of Materials. It says to select the drawing view that you're going to generate the table for. Just click on your exploded view. Now there are a lot of options that come up that give you control over the appearance of the table. We're not worried about any of these today. We're just going to accept everything as the default option. Just click the check mark, and the table is created for you. It's just following your cursor around, waiting for you to click and place it. I'll put it up there at the upper left. And then you can resize these columns if you need to. like in this upper right box, I really just want that to say quantity. I don't want the direct view card in it. So just double click that and we can delete that text. But all of this is created automatically. It identifies the name of each one of these parts, just whatever file name I saved it as, and identifies how many of that part are in the assembly. And if there was a description that I saved with the part, that will be filled in automatically as well. So that's how easy it is to create the bill of materials for your assembly in SolidWorks. Now the last thing we need on this page is the balloons that identify which item is which from the bill of materials. And again, that's fairly automatic. It's just a matter of remembering which button to click. On the annotations tab, we use this auto balloon button to create those item numbers. So click auto balloon. You can choose different layouts if you want them all down the left side or around and all surrounding. You can choose whether or not you want it to ignore multiple instances, like where you have two of the same part. Do you want each part labeled or just one of the two parts? There's a whole bunch of options we're not too worried about. Just accept the defaults, and then you can click and you can reposition these balloons just by dragging them around and putting them wherever you want those to be. So, now in this case I did tell it to ignore duplicate instances. So like this side here is identified as part number 4, which corresponds to the bill of materials. All the numbers match what's in the table. But this side here didn't get labeled. If I want to go ahead and label this myself, I can do that manually using the balloon option button here. Just click and then just click on whatever point you want to label, and SolidWorks goes ahead and creates the correct number to match the bill of materials table. So you can do that as well. And just to show you, again, how intelligent SolidWorks is being here, if I click on that side plate balloon, okay, that identifies it as the side support part. If I click on the arrow and drag it over here to a different part, notice that the number automatically updates to tell me, no, this part is the side gear part. Okay? If I drag it out here just into space, it gives me a question mark because it doesn't know what that is. But SolidWorks is actually pretty intelligent at laying these things out. And this is, in AutoCAD, we'd actually be drawing the circle, putting the number in it, drawing an arrow, and then if we realized we needed a different configuration of the model, we'd have to start completely over. I mean, this is really, I don't mean to bash AutoCAD, because it's got its function, but so much happens automatically in SolidWorks that you would spend hours doing in AutoCAD. I really hope that you can appreciate SolidWorks functionality that you wouldn't have in some other programs. Okay, so I think that's everything you need to know for this sheet. Do you have any questions about anything that we've done here?
When you're making a new sheet, is there any way to copy the format so you don't have to type your name or do the CA every time?
Not that I know of. I think when you insert a new sheet, it's going to go back to the default settings, whatever you had selected for the very first sheet, but it's not going to copy new information into it, unfortunately. Good question, though. Any other questions?
What sheet type is this that we're using?
This, if we look at the drawing, this is a size A landscape, ANSI landscape. Okay, so let's take a look at sheet 3 here and make sure you know what you need to for sheet 3. Again, we'll go add a new sheet, turn on the title block, properties, display sheet format. Okay, now this view in the upper left, this is kind of your parent view for the other views, okay? Because you're taking a section view through it, that's what generates this view. Then an auxiliary view of this view gives you this one, and a detailed view gives you this one. So this is the parent view of all of your other views, and this is just a top view of the assembly. So if we put a top view in, we go to View Layout, Model View, we can choose Top View and place that there. Okay, but notice that it's oriented in the wrong direction. Also doesn't look like it used the sheet scale, which is strange. Use sheet scale. You can do a two-dimensional rotate. You wouldn't want to do a three-dimensional rotate because you'd never get it aligned perfectly. But you can do a two-dimensional rotate here using the Rotate View button and choose the view. And then we just want to rotate this one by 90 degrees so that it's facing off to the side instead of facing downward. Okay? And then we can do a section view. We'll do a horizontal view, section view right through the middle. Place that view down there, and it gets labeled for us. It gets crosshatched automatically for us. We can do the detail view, just defining a circle, something like that. And, oops. And then place that over there. Remember how to change the scale. If we want this 1 to 4, just click on the view, go down to where its scale is defined, and choose whatever scale you want. And if it's your scale that you want is not listed, remember you can always go to user define and type in any numbers that you want to. Okay, so then we need an auxiliary view. So last time we talked about this, we didn't have a good example of why you would use an auxiliary view, but this is a perfect example. If you wanted to create a view that looks straight down the bore of the telescope, okay, there's no other view option that would really do that for you other than auxiliary view. Okay, none of your projected views would give you the correct view, but if you do an auxiliary view, you can select a reference edge. I'll click on the front edge of the telescope, and then SOLIDWORKS gives me the view looking straight down the bore of the telescope. Okay, now SOLIDWORKS is maintaining the alignment, so I can't drag this up and down. What we need to do is just right-click on the view and say Alignment, go to Break Alignment, and that breaks the alignment so that I can drag this anywhere I want on the screen or on the page. Now again, this one is rotated. You'll want to click on it and do the two-dimensional rotate and just kind of drag it around. It's a little bit jumpy, but just play with it a few minutes and you should be able to get something that's pretty much vertical. All that good. And remember, if you notice that, for example, your section arrows or your dimensions are different than what's shown in the PDF, like this has the double arrow in the drawing. By default, I'm just getting a single arrow. Remember what is controlling the appearance of dimensions in the section arrows and stuff like that? Do you remember what that was called? That was the drafting standard. Okay. So to change that, go to the Options button up at the top, Document Properties, change it from ISO to ANSI, and that changes the appearance of those things. You'll fill in your name in the title block. You'll add some dimensions there. Let's see. Oh, the center mark. I didn't put that in this view anyway. But also, just remember, if you wanted the center mark here on this circular opening of the telescope, just remember that's on the Annotations tab, center mark. Click on something circular, and that gives you the center mark to show, like, designate the center point of the telescope bore. Okay, so remember you can go to File, Save As, and sheets need updating. And you can change that to a PDF to turn it in. Also though, remember to save the drawing as a SOLIDWORKS file. If you need to come back and edit it later, remember to go and do Pack and Go. Okay, because that will save your drawing and the assembly and all the parts that go into it, and you can save it in one single zip file, or just save all the stuff in one folder if you want. That way you've got everything you need to open this up on a different computer later on. So, do you have any questions at all over anything that we went through today? Okay, if there's no questions, go ahead and go to the second half of the lab, and if you have any questions, I'll stick around up here if you need.